In the last video, we introduced the motion of charged particles, and we introduced how particles can move up or down, and that motion is happening vertically. In this video, we're going to introduce a new but exciting concept, which is motion of charged particles, but horizontally to the electric field. So it's possible to put a positive charge in a field so that it can be deflected towards the negative charge. It is possible for us to derive some laws around this fact, but first, let me show you what I mean by this. Okay, so let's assume you have a positive charge like this, right? It is possible for you to project it horizontally. So project it like so, okay? So as you try to project it like that, like so, it's going to move in a path that is initially tangential to that motion like that, but then over time it's going to move down like that, right? So it's following that curved path simply because we have an electric force that is causing it to move down, right? Sort of like causing it to deflect down and down and down and down and down and down and down. Now, if you've done, I'm pretty sure you've done projectile motion. And we said if you have a projectile motion, let's assume you have a ball at the edge of a cliff. If you project it, it's going to move down like so. And as that motion happens, the force of gravity is acting down on it. In a similar sense, the electric force can act on this ball, causing it to move down as much as the force of gravity would make it move. So you see following that path, and the moment it exits the field, you just continue in a straight line like so. Right? So that is essentially how a particle can move in what is known as a parabolic trajectory. Okay, so it's more like a curvature, a trajectory that is like a curve. Okay, so essentially everything you've learned about projectile motion will now apply. The formulas, v squared is equal to u squared plus 2as, equations for vertical motion versus horizontal motion, everything you learned for projectile motion will now apply in this instance. The only difference is that the force that will be causing acceleration will be the electric force. But you can now use the equations Vy is equal to uy minus gt, all the equations that we had. You can be able to find the height. In this instance, you can be able to find the range, how much it has moved. You can be able to find the time taken. All the equations that you're used to, you can be able to apply them. So just keep that in mind, and the acceleration can easily be found using this formula, QE divided by m. So the amount of deflection that is experienced by this particle will depend on three factors that we're going to explore together. The first one being mass. Okay, so the mass of the object will affect the deflection that object is going to experience. So the greater the mass of the object, so if it's very heavy, the smaller the deflection that is going to be present on that specific object. Now you can see it from that equation that we have on the right. If the mass is bigger, so if you look at this, if the value of m is very big, this will cause the acceleration to be smaller. 1/10 is way bigger than 1/100. Okay, so if the acceleration is very, very small, that implies that the force that will be pulling you down will be less. So essentially, the deflection that you're going to experience will also be a little bit small. So as you can see in that illustration, that is for a bigger mass and that is for a smaller mass. The next one is charge. Okay. The greater the magnitude of the charge that you have, the greater the deflection that you're going to encounter. In that illustration, we have plus 2q and we have q, right? One is the bigger charge than the other. And if you look at that same equation that we have over there, if the value of q is bigger, so if you have 2q, that essentially means that the acceleration will be bigger. So if the acceleration is bigger, a greater force will cause you to move down. So a greater deflection will therefore be encountered. So we can therefore use that analogy to better understand what will be happening, right? If you look at that setup, that is the bigger charge, that is a smaller charge. So essentially experiencing a greater and greater deflection. Okay. The next up, we have speed. The greater the speed that you have, the smaller the deflection. Think about it. If you're going to project something very fast, there'll be very little time for you to actually experience some deflection, right? It'll be a lot of drama, but it's moving fast on its own. It doesn't really need a lot of deflection for it to occur. So, because of that, the greater the speed, the smaller the deflection that you're going to encounter. So basically, if a particle moves in a uniform electric field, the particle will experience a force at right angles to its initial direction, and the particle will follow a trajectory, right? It will be affected by three factors: the mass, greater the mass, the smaller the acceleration, and the lesser the deflection. It will also be affected by charge. The bigger the charge, the greater the deflection. It will also be affected by speed. The greater the speed, the smaller the deflection that you also encounter. That is essentially how you need to be thinking about this. So a lot of questions will come. They'll give you questions like this. Path of an electron, you need to figure out, hey, if it's an electron, it's likely going to be deflected towards the positive charge because it's positively are, charged. So you're going to experience a force in this direction, right? So you should therefore be able to think that, hey, so my path would therefore just be like that. Okay. You can now be able to find the force acting on the electron. Acceleration is goes to QE over m. You can find the acceleration. Do all of those calculations, right? Why does it follow a circular path? We'll get to solve a lot of questions, but essentially all you need to think about, if you have a proton entering is positively charged, so it will just follow that path, right? You need to think about what are the factors. For example, the neutron compares the helium nucleus to the proton. So you need to know which one is a bigger mass, which one is a bigger charge. How does it affect the nature of the curvature or the speed that you're going to have at the end? But don't worry about a lot of questions. We'll solve them as time progresses. During all this motion, we actually neglect, right? We don't consider the gravitational field effect, the effect of a gravitational field. Why do we do that? Well, this is true because the mass of the object will be so small that we can't even talk about the force of gravity being negligible. QE is a bit different, right? The charge can be a bit bigger, but the mass, it's a bit small. So the gravitational force can be calculated by saying F is equals to mg. So if you take the mass, you multiply by g, which is the acceleration due to gravity, you can therefore be able to calculate the force. So the mass of an electron can be given by that. The force acting on that electron can be given by 9.8. Multiply the two, you get like 8.93 times 10 to the power of negative 30 newtons. So that is the total force that will be acting on that electron, causing the electron to move down. And that is quite negligible, right? You can't really consider this when you're actually doing motions of these particular objects. So that is why if you have a field like this, rarely we can only see electric force, of course, right? Like Fe. But rarely do we even see Fg, right? The force of gravity will be like so small that we're like, why consider it? Why bother? We don't really bother to consider that at all. But yeah, that's essentially it. That's all you need to know about the motion of charged particles. Most of you to really understand this will be solving a lot of problems so that we can be able to improve your understanding. But for now, we're just going to be going through all the theory, then we'll get to problem solving a little bit later. I hope this was helpful. In the next video, we introduce Coulomb's law, how Coulomb cheated and ripped off Newton. It's going to be a fun one. So I'll catch you guys in that video.